Hi, my name is Devanshika. I'm currently a biology and computer science major at UIS, entering my senior year this year. And I would like to introduce the lovely Dr. Pappu, who is also in the interdisciplinary field of computer science along with medicine. Hi, Dr. Pappu. Thank you for joining us today.
It is my pleasure to be here. Thank you for inviting me.
Of course, of course. And would you like to begin? Should we start? Okay.
Yes.
All right. Okay. My first question would be, could you describe your journey from computer science to neurosurgery? What inspired you to pursue these fields?
So I was at Miami University in Ohio, and I was an undergrad, and I was interested in studying economics. And when I asked the economics department what I should do to prepare to go to grad school, they said you should major in math and minor in economics. So I took that up and majored in math, minored in economics. And then along the way at Miami, we had a minor in operations research. And so I thought, well, this is interesting. And operations research, it is a lot of different things to different people, but it's mostly a mathematical toolbox, and it allows you to describe systems. Broadly, it is the study of probabilistic systems, optimization, especially with constraints, and in some ways, decision analysis. In some places, it's known as industrial engineering. In some places, operations research. In the business context, it's related to supply chain economics. How do you get your FedEx truck to deliver things from throughout the day in the most efficient way? So that's where it's logistics. It can be data networks. But at the end of the day, it's a lot of really interesting analytical tools. So when it came time for graduate school, I was still on the fence about economics and operations research. So I applied to both programs, and then I got into operations research as well, and decided to go that way. So I went to MIT and studied there. I did my master's and my PhD in very traditional topics. In my PhD thesis was production planning with due date scheduling. Subsequently, I moved to Yale and did postdoctoral work in computer vision. And nowadays people are pretty familiar with it, but essentially it's how do we get computers to understand visual data. So we have image recognition on the computer, we have video recognition. I mean, we're all pretty familiar with that now, but all those years ago, it was still something to be worked on. And a lot of those concepts, I can definitely see how things have been developed. I then moved into medical image analysis, and that's where instead of just generic or general purpose types of studies, it's how do we use our engineering techniques to understand medical images. And for example, I worked on looking at the MRI of the brain and segmenting, like tracing out different structures in the brain. This was a topic that was actually given to us by a couple of psychologists who were studying autism and Tourette's syndrome, and seeing if you could correlate structures in the brain to their clinical problems. So having done this for a little bit, I thought I was actually more interested in being the person on the other side. So the clinician being able to come up with that problem to bring to the engineers and potentially to be between them. But I did think that being a doctor would be fun. So I went back to medical school, actually started in general surgery, and then ended up switching to neurosurgery, which has been really fun. It's pretty hard work, the training, and in a lot of ways it continues to be pretty hard work. but it's very rewarding in terms of patient care. And it's pretty cool in terms of the ability to use technology and to develop new technology.
Wow. Wow. That
So,
is so,
so currently I'm at University of Illinois, Urbana-Champaign, and I am a neurosurgeon at the hospital here, and I'm part of this medical school here, which is the first medical school in the world to train engineers to become physicians. So when I heard about this place a few years ago, I was in Chicago at Loyola University, and I thought, wow, this is where I need to be. And
mhm,
a job opening here, so I applied and I came. And over the last couple years since I've been here, of course, I have my clinical practice, which is not just rewarding on a patient by patient basis, but also is a context in which I can think of ideas and then communicate them to engineers and try to come up with solutions for them. And I've done that throughout my career where I have collaborated with engineers who can do really the detailed work and have the ongoing expertise to do that. And to some extent, I'm the domain expert about neuroscience, but still can bridge the two communities to communicate that. Um, and so over here, in addition to the clinical job, I'm the director of student research. So I help the students here who are training to be physicians, but more significantly training to become physician innovators to help them to find projects that they can develop. So some of them come in with a lot of expertise. In fact, a lot of our students do come in with experiences in engineering, in technology and medicine. But some of them even come in with a startup company already or a PhD already. And our curriculum is really based in how do we integrate that mindset to medical problems. So, for example, when you're on your pediatrics rotation in medical school, normally you would just take care of a bunch of kids and do a lot of reading and seeing a lot of pathology. But here we actually have engineers who direct part of each week, sort of doing engineering rounds, and we call them engineering partners. And what they do is they facilitate that process of innovation, the biodesign philosophy, so that the students have to come in, present several problems that they have identified in their experience on the ward, and then identify one of those problems that perhaps could be developed further, either for a process or a device, something like this, or an algorithm or an app. So it's a really interesting place to be where that approach is integrated into medical education.
wow. That sounds so interesting. I've never seen like an engineering based medical learning, like just the whole school.
Yeah, we're very proud of it, and the curriculum that we have obviously is very unique. That a lot of the elements we've had to design on our own. The medical school with this mission has been here. I think we've graduated 2 classes so far, and they've matched pretty well into traditional residency programs. And so that is very good, but the curriculum itself continues to be just like with any engineering problem or anything in medicine, a world of continuous update. And we're very proud next spring we'll be hosting the Global Health Consortium here with medical schools from around the world and companies And part of our mission a little bit is to introduce this notion to other medical schools to consider such a curriculum, innovation-based, engineering-based. There are several other schools in the United States who have this perspective, but we certainly are the ones who are the leaders in that.
Course. What would you say some of the biggest challenges were when you were transitioning between these fields or just combining them?
Yeah, I think when I went from sort of that engineering place to medicine, one of the ideas of medicine is that you have to memorize a lot of things, that there's thousands of factoids that you have to memorize. But I have always thought of it as more a systems-based approach. So how do I build, a framework to think about this set of things? I mean, sometimes you have to just, muck it up and
Yeah.
memorize a bunch of stuff. But a lot of times you can think of it very systematically. And I think of like the periodic table in chemistry. You can look at the different elements, you can just take it at face value, but the more you work with something that's so simple and elegant, you can see that there's structure there and there's a lot of information. So if you just have your periodic table on an exam, there's a lot that you can derive from it. And so that's always been how I've thought about being in medical school. Like my whole approach to medicine has been about how do we build a system to consider something, or how do I analyze this in the context of a system, as opposed to, oh, here's a problem, let me solve this one problem. For me, it's always, can we at least conceptually think of this as part of something bigger? So if we solve it once, we've solved, a whole bunch of variants of this. And so it certainly informs the way that I approach things. I think coming from a quantitative background, even the ability to write computer code forces you to think in a very systematic, structured way. And that, I think, also applies to how you approach medical problem solving. It's not just, oh, here are a bunch of different diseases, could it be one of these? But it's like, what are the things that are similar? What data do I have that, fit a certain process? Is this some kind of inflammatory thing? Does this make sense? Does it, so it's much more of a systematic way of thinking about things than I think my stereotype of what medical education was like. So even though I didn't have this as my training naturally had resulted in me thinking of the world this way.
What advice would you give to students who are interested in this interdisciplinary career?
Well, study everything.
Yeah.
Like I think that obviously that some people won't like to hear that, but at least try things out, So if you're in an engineering field, there are opportunities for you to do biomedical engineering just to see, like, do you like that set of problems? If you take, there are really only a few courses that are prerequisites for medical school. And it may have changed more recently, but it's just biology, 2 years of chemistry, and 1 year of physics. If you're taking engineering anyway, you probably are taking physics. So you're going to take a physics that is actually more advanced than what the pre-med students need to take. And then if you can take a little bit more, if you're a chemical engineer, you probably have all the prerequisites already. I don't know if they require biochemistry now or not. They did not when I was studying, when I was preparing to apply. But I already had all the coursework. And so when it was time for me to make the decision to switch, I needed to just take the entrance exam, the MCAT. And, that's an exam you have to prepare for. There are a million questions and you can just prepare for it. And you have to know yourself what you need for that kind of test taking. But a lot of it is just as you switch fields to also respect the teachers you have on the other side, the people who come through traditional tracks, because they are bringing a different worldview than you are to that problem, and being able to incorporate and bridge those things is really important.
How are you able to balance your role as a clinician, researcher, and educator?
So I say to my students who are interested in research, at some level, patient care always comes first. If I'm on call and there's an emergency, I just have to go and take care of it, even if I'm in a meeting for administration or research. And that is something that is well understood in these kind of environments, academic medical centers and whatnot. But it is nice for me that I have protected time. So if I'm on call for the weekend, my partners will cover everything for me until 5 p.m. So it really gives me a lot of sense that I can focus completely on the other elements. But if it's my patient, if it's somebody that I operated on or that I've been following, I still will take care of them. They're my patient, and we have a very special trust relationship, and I would not want to violate that. But I wouldn't, take on a new patient during that time. So it's important to have that opportunity. And a lot of places it's not so well defined, but between Carle Foundation Hospital, that is my clinical employer, and Carle, Illinois College of Medicine at the University of Illinois, we have a great system that's set up like that. So I feel very supported to be able to do both things. But the reality is that I do a lot of things in the evening, and Zoom meetings are really helpful. And even just meeting other engineers or clinicians, a lot of times things get pushed into the evening. And honestly, I find it's so much fun that I don't really think of it as anything like work. It's just fun.
And this is the last question, but how do you think that the integration of various disciplines will shape the next generation of medical professionals and researchers?
I think it's a really exciting time. We see artificial intelligence in everything. It's such a buzzword. I was working in artificial intelligence when it still was called neural networks. And so if you go back, a couple of decades, you'll see that I have some co-authored papers there. But I think that technology is in every facet of our lives, and it clearly is in medicine. And to be able to bring that formal training from quantitative analysis and methods, and engineering, and that perspective that you have from your training into medicine, I think is going to absolutely put you ahead of your peers in training, because they will just be playing catch up, learning some statistics, learning some basic AI models, but you'll be able to write the code that goes behind them and change the model. Whereas they'll be stuck with whatever the software company provides for them. And you'll know what underlies all of that in a much more familiar fashion. So I encourage everybody to follow this very tortuous path, but you'll have fun every step along the way.
Thank you so much for joining us for this interview. I feel like I learned so much about the future of the career that I'm about to start whenever I do.
Oh, yeah, definitely. You'll have to come apply here and come visit
I
us.
will, of course. I will. Well, thank you for everyone for watching and joining in. And I think that's it.
Thank you so much.
Thank you. Thank you so much for coming.